So let's talk about Amazon Bedrock. So Amazon Bedrock is a service provided by Amazon to create GenAI applications. So this is a platform where you can create your GenAI applications, and it works as a middle layer between your application and the foundation model. Okay. So how it works is you open your Amazon Bedrock, and there you just have to select a model. Okay. Then you can just try out that model over there. Like the foundation models, it has a lot of foundation models provided, like Anthropic Claude, Metalama, Amazon, Titan, and a lot more. Okay. You just try your model, and then once you are decided with which model to use, you can integrate it with your application. So basically, the applications which you already had, you had to add GenAI capabilities to it. So you can have a bedrock in between. So your application will be calling the bedrock, and the bedrock will be forwarding your request to the actual foundation model. And then the response from the foundation model will again come to the bedrock, and bedrock will forward it to your application. So let's see it. So here we have the Amazon Bedrock. So we have the model catalog over here. So if you see, a lot of these providers are there, and from each provider there are multiple options. Like you have here the Claude from Anthropic, then some Amazon models you can see Nova and Titan. Okay, then you have DeepSeek models, then some models from Google. You have even from OpenAI, NVIDIA. So you have a lot of options here. Almost all the options available in the market for the foundation model. You have them here. Okay. So now how to use them up is first we can try out the models over here. So how do we try? Let's say we are going to try a simple light version, which is the Nova 2 Lite. Okay. So we can just click here and click on open in playground. Playground is basically a place where we can try out the models. Okay. Now we can simply write the prompt and get the response. Okay. So we can try out the things, try out the models over here. And even we have a compare mode here where you can select multiple models, and then you can write up your prompt, and you can compare the response from both. Okay, so this is used when you have to decide which model to use for your application. So now here we can see like it's a web portal provided to just test the models. Now if we actually have to integrate our model with our application, then what is the way? Then you see here you have the API format over here. Okay, so you have to use the same API format and then link it with your application. In your application, you have to call the API, and within the API, you will provide it like the model name, the model version, and then your message. So it has a specific format for every model. There is a different format. You have to provide your message in that specific format, and then your response will come back to your application through the Amazon Bedrock. Now, Playground, it's a place to test and compare foundation models. We have already seen. Pricing, if we say for the Bedrock, there are two modes generally, which is pay as you go and provisioned throughput. Pay as you go is simply like how much of input and output tokens you are using up. Based on that, you will be charged. And provision throughput is you reserve the capacity for you, let's say for a specific model, and then maybe for a specific amount of tokens for a specific amount of time. Okay, so generally provision throughput is cheaper in all the AWS services wherever you have to have an option to pay as you go and provision throughput. So provision is generally cheaper. Pay as you go is costlier, but it is pay as you go is like if you don't use, you don't have to pay any charges at all. But provision throughput, if you reserve throughput for you, then obviously you have to pay whether you are using or not using. So there can be questions on this pay as you go and provision throughput for any of the applications. So remember the concept and the difference between the pay as you go and provision throughput. So we have seen how to create a GenAI application using the Bedrock. Now, when we create a application, we have to have some safety rules over there. So for that, we have the guardrails in Bedrock. So guardrail, if you simply say, it's a way to implement responsible AI concepts. Let's see guardrails over here. So you can create your guardrail. You have to provide it a name, and then you have to select which one are applicable. The first one being the harmful categories. So harmful category, you can just select which of the categories you don't want your model to respond on. So we can just simply configure over here and we can select different categories over here like hate, insult, sexual, violence, or misconduct. And then you can select it is like block or just detect. So first is the harmful category. Okay. Next one is the prompt attacks. So prompt attacks like jailbreaks, prompt injection, and prompt leakage, which we have seen earlier. Your guardrails can help in them as well. So here you can enable the prompt attack, and then you can simply set it like detect or block again. So will be it is automatically going to save you from prompt attacks. Okay. Next one is you can add a custom topic to be filtered out. So custom topic filter. So let's say you don't want your application to talk about a specific topic at all. So you can add that topic filter. Or you don't want a specific word to be used by your model, whether it's in the input or in the output, you don't want that word to be there. So for that, we have the custom word filter. So here you can add your word and then you can select like you don't want to have this word in the input or output or maybe both. So you can select that up here. Next one is the PII masking. So this one is again automated. Your model will automatically detect that it is a PII and it will mask it. So it's like sensitive information. So PII, you can uh, just add like what type of PII, like name, phone number, email. These all can be type of different personally uh, identifiable information. So you can select which type you want to mask, right, or block. So PII also we can handle over here. And then one again important thing is the grounding and reasoning check. So you have your grounding check and reasoning text, reasoning check. So both of these are used to avoid the case of hallucination. Hallucination we discussed while discussing responsible AI. It is a case when your model response seems to be correct, seems to be factual, but it is actually not correct. Okay. So with the use of grounding and reasoning check, you can avoid such cases. So in this case, your model is going to recheck and have a high, you can set it up like a higher confidence score is there, then only you provide this response. Okay. So with that, you can avoid hallucination using guardrails as well. Next, let's talk about Bedrock post training. So we have seen we are in a Bedrock, we are using the foundation model. So foundation model, we already know they are already trained on a vast amount of data. Okay, on a general data, vast amount of general data they are trained on. But now you have a case where you are, let's say, integrating your uh, application with, you are creating a Gen AI application, let's say, for your marketplace. You have an online marketplace and you are creating a Gen AI application for it. Okay. So there you can have some specific cases, specific use cases, which a general foundation model might not understand. Like product names, your product names would be specific to your marketplace, right? Your product catalogs. So those are specific cases, right? And then your policies also be specific to your company, like return policy or let's say compliance policies are there, or some restrictions are there. So there can be specific knowledge about your use case only. Okay. So for that, we can use the post training. So it is like specialize your model for a specific use case. So under the post training, you have first option is fine tuning. So in fine tuning, we are going to provide the model with labeled data. Okay. We are going to train. It's already a trained foundation model. We are doing a post training on it. Okay. So we are now providing it with labeled trained data. And then we are training it for some specialized task. Okay. So the example we can think of is we have our company policy documents and compliance documents. So those documents we can hand it over to our model to learn from them. So this is your fine tuning the model. Next is the continued pre-training. So in continued pre-training, you are going to provide a large volume of unlabeled data. Remember the difference. Fine tuning, you are going to provide labeled data, and continued pre-training, you are going to provide unlabeled data. So unlabeled data is being provided to get a deeper knowledge on a specific domain. Okay. So let's say use case like you have product catalogs for your market, the online market which we were talking about. So you have product catalogs. So those product catalogs you can provide it to your model so that your model now understand if a user asks about a specific product, it like detects like it's a valid product in our market, right? And maybe it also knows the description of that model, or if it's whatever like information related to that product, it has that information because you have trained it with that specific data, the catalogs, the product catalogs, you have trained it. So we have to remember post training is a costly operation because generally what we were using is a already existing base foundation model. So we can simply ask our questions and it will respond. But if you are doing a post training, So it's simply like creating a specific instance for you only and then train it with the data which you are providing, because Amazon is not allowed to, like, whatever data you are going to provide cannot go to the base model training, right? The base model which is publicly available to everyone should not learn from the your specific data, right? It's a security issue, it's a security and compliance issue. So Amazon cannot be using your data for training the actual public model which is available to all. So there would be a specific instance for you, and that would just be trained on your data, whether you are using a fine tuning or continued pre-training. So it's a costly operation. Remember that. Now let's talk about RAG in Bedrock. RAG is retrieval augmented generation. So we have seen, if we have to provide our model with specialized knowledge for our use case. So in that case, we can use the fine tuning or continued pre-training, but those were costly operations. The another option for providing our model with specific knowledge for our use case is the RAG. So RAG is like a knowledge base for your models. Okay. And here you are going to provide it with some data sources. You are linking your model, basically not exactly the model, the Bedrock model. The Bedrock you are linking with some specific data sources. Okay, and those are not actual the training data. Those are not going to be used for training. Those are just being used for answering your question. So here we how this works is for C. So let's say this is your foundation model. Okay, let's say this is your base foundation model. We haven't do any fine tuning or anything on it. Okay, and here is your application. So when a user asks a question, it is going to forward, it is going to find relevant information related to that question from the REG which you have attached. And then with that relevant information and the question itself, it will send that to the foundation model. And then your foundation model will respond. So it's basically your it's the foundation model is not being trained from this data, the REG data. Okay, it's just using it as a extra knowledge. Okay, so this is not any kind of training. This is just a extra data or external data you are providing to your model to respond. So obviously, since you are not going to do a training, it wouldn't be that costly. So the databases which you can attach over here is like S3. You can have your documents in S3 and you can attach it with your Bedrock or MS SharePoint, Salesforce, Confluence. So any of these you can attach it. Obviously, like we have already discussed, there is no retraining cost because we are not training it. We are just giving it access to our data. And another important thing is it can have access to real-time data. So in training, the fine tuning or continued pre-training, that has to be done before we are using the model, right? So we have to train it, then we have to start using it. Or maybe even after using some days, we can again do a post training on it. But it's not real time. We cannot get a real time data at the time we are calling it up. We are questioning it up. But in this case, since every time you ask your question, at that time it's going to your database and then attaching the information. So this database can keep on changing in real time. Okay, let's say you have your S3 and there you have let's say stored your something like product catalogs, right? So that product catalogs can keep on changing. Okay, but your application will be getting the real time data every time. It's not just like static data over here. This data can keep on changing. It's just a connection between it. Okay. So even your data changes, it will always be getting the latest data. So that's why in a while using a RAZ, it's always a real-time data which we are using. Now let's talk about agents in Bedrock. So a agent is basically a way to allow your foundation model to perform tasks beyond just providing a response. As of now, what we have seen is how a model works is you ask it some question and it will respond. It will provide a response. It can be like a text response, it can be a image response or video response as well if we ask it to generate an image or video. Okay. But it's just providing you a response. It's not doing some actual task. But if we need to do actual tasks, then in that case, we can use the agents. So tasks like reading or writing to a database or executing a code or calling a API to perform any task. Okay. The agents uses chain of thought. Like a chain of thought we have seen earlier, it's a technique where we break the task into steps and then perform those steps one by one. Okay. So let's say for example for agents. So let's say you the one which we were discussing, like we are creating a let's say a support chatbot for our market application. Okay. So now let's say a user comes there and is ask the chat application like I want to cancel my order. Okay. So your agent is going to first break the task into multiple steps, and the first step should ideally be getting the order ID. So it will get the order ID from, it will ask from the user, like, please provide the order ID. Okay. Then the next task would be it should first validate if it's a valid order ID. So for that, it has to connect to database. It has to read the database. Okay. So in the database, there would be a orders table. There it would be finding the order ID and checking if that order ID exists. If it exists, then it has to, the next steps would be updating the status of the order. Okay. So in the next step, it can uh, go to the database and then update it with the order status as cancelled. Okay, so these can be the multiple steps which it can break uh, the task into. So how your model is able to perform task is the action group. Action group is the way like your model is performing any task. Your agent is performing any task. Okay. So action group are actually comprising of two things. One is the directory and one is the executor. So directory is basically the possible actions. Let's say update order status is a possible action, right? So, and what all would be the inputs required for this action and what is the expected output? Okay. So it can be defined like update order status is one possible action, right? And the input required for it is let's say order ID. Okay. And then the expected output is maybe like a success or failure updating the uh, order status. Okay. So these different actions can be there within your directory, and each action has to be backed by some code, right? And some code means some code has to run and do the actual task. So for that, we have AWS Lambda. So in most of the cases, the executor would be AWS Lambda. So whatever the action is there, that is each of the action is backed by a Lambda. Okay. Lambda function where the code is written to take the inputs from the agent, do the actual work, and then response is back to your agent. So this action group is the uh, actual thing which does the work. Your agent needs action group to perform task. to perform actions. You can attach RAG to your agents as well, like your knowledge base you can be attaching to the agents. There would be some questions attached in the YouTube description related to the topic. Please try them out.